In this video, I am going to solve the problem 27th from chapter 17, Waves Part 2. A violin string 15 centimeter long and fixed at both ends oscillates in its n is equal to 1 mode. So you have a violin string and its length is 15 centimeter. At both end of the string is fixed at both ends to oscillate, and it will be oscillate in n is equal to 1 mode. That means the fundamental frequency, right? The speed of the waves on the string is 280 meter per second, and the speed of the sound in air is 348 meter per second. So don't get confused about both speed. The first speed says the speed of the waves on the string, which is v is equal to square root of t over mu, that value, okay? And the second part one is speed of the sound in air, the constant value 348 we are going to use here, okay? And we are going to find two answers. What are the frequency of the emitted sound wave and the wavelength of the emitted sound wave? So first one, we are going to find the frequency of the emitted sound wave. Second one, we are going to find its wavelength, right? Okay, first of all, I'm going to write what is given in the question. So the length of the violin string, they mention here as 15 centimeter in terms of meter, which is 15 multiplied by 10 power minus 2 meter, and its fundamental frequency, so n is equal to 1. So the speed of the waves on the string, so better I can write v string, which is 280 meter per second, and then the speed of the sound in air is 348 meter per second. And first I'm going to find the frequency, and then I'm going to find what should be its wavelength. And we know the frequency, which is equal to nv over 2l. This is a general rule for the frequency calculation. So here this n is equal to 1, which is fundamental frequency. So I'm going to substitute the value here. In place of this v, I'm going to substitute what is the speed of the sound, speed of the wave on the string. Clear? And the length is already mentioned. So we can get the answer for the frequency directly. So a part f, which is equal to n carries the value of 1, and here v is nothing but the speed of the sound, the speed of the wave on the string, which is 280 over 2 multiplied by the length of the string is 15 centimeter, so 15 multiplied by 10 power minus 2 meter. So let's see what is the answer. I'm going to calculate 1 multiplied by 280 over 2 multiplied by 15 multiplied by 10 power minus 2. I got the answer as 933.3 hertz. Clear? So this is the answer for the first part. For getting the answer for the second part, we are going to calculate the wavelength, right? So we can directly use the rule speed, which is equal to frequency multiplied by lambda, right? Therefore, wavelength lambda, which is equal to speed over frequency, this is nothing but the speed of the sound in air. And for frequency, I am going to take this value and substitute here. So by that you will get the answer for the B part. Therefore, lambda equal to 348 over 933.3. So let's see what is the answer, which is 0.3728 meters. So I can write to 3 digits 0.373, and the unit for the lambda is meter, right? So this is the answer for the B part. Clear? That's it. Thank you.